Alright, now the fun can begin on the main chassis. I'm going to leave that high voltage unit out of the way for the time being. That kind of opens things up down here. I also went ahead and stitched together the Sam's Photo Fact. I had downloaded a scanned copy from the Early TV Foundation, which prints out on separate 8.5 by 11 sheets. So what I did is just took a straight edge and a razor blade and cut them up and taped them together. So there's a full schematic, which I've noticed is a little bit different from the Riders, and it matches mine better. So for example, on the 6BG6 horizontal output tube, this copy shows off the grid a 220K and an 18K, whereas on this we just see a 220K going down here with no 18K resistor in sight, and that is what I found in my set as well. And the other thing I like about the Sams is these, which I also printed out and taped together, which are the component locators with the photo that you can use to match up to your chassis, assuming it hasn't been heavily worked on, and mine has not. So the photos are basically identical to my set. Now, I was curious earlier whether or not any work had been done other than the little things I noticed in the high voltage circuitry, but if this is any indication, then some of these caps have been replaced. As you see, the same type of white looking stripy caps here and here, and like this bumblebee I've got down here, you see here. But on mine I got a couple red guys, maybe three, one here, one here, one here, and on the Sam's they're the striped kind. So perhaps a few of these have been replaced. But some of these that are kind of hanging out, like this guy and this, I think may very well be original, because you see him on here, sitting there and there. Regardless, I'm going to be replacing them. So I think I'm just going to carpet bomb them and just start here and start working my way over. And I'm also going to replace resistors that are out of tolerance or look crummy like this. I really don't like these old type power resistors. You can see all that green corrosion. Eventually it works its way inside here and they go open. Even if it measured okay right now, I would not trust that to hold up for any length of time once the set's operating. Well, I tried to get my bearings on the set in this area, and it seems things aren't going to be quite as straightforward as I'd hoped. For example, I was trying to match this area up. In particular, this capacitor right here, C69, should be right in here, and there isn't one. Well, I tracked it down, and that's 0.047 going to pins 6 and 7 on the noise clipper, 12AT7. Well, if we look on the tube chart, bottom view, 12AT7, that's this guy. And if we look at it, pins 6 and 7 are not connected together, and there is no 0.047 capacitor going up in there. So I referred back to the Riders info, which also shows a 12AT7, 12AX7, but this 12AT7 is labeled as first video amp and sync amp, and not a noise clipper. That they show over here at a 12AX7. And further looking on the schematic, here's that noise clipper, 12AX7, pins 1 and 2 connected together with a 0.05 and a 470K. And if I track that down, it's actually down here. There's the 470K going to ground, and it's actually a 0.047, even though it says 0.05 on the schematic. So clearly there have been some design changes made along the way. Although the tube charts will match up, the function of the tubes is different. Looks like they switched some of the triodes around. So what they call 12AT7 first video amp, first sync amp, 12AT7 is a video amp, and I'm not sure what the first sync amp is. Well, might be this guy. I think I have a couple 12AX7 triodes here and a couple over here. And so that's the SAMs, and the Riders I think has, so we got 12AT7, a 12AU7, and a 12AX7, and then another 12AU7, two 12AU7. So I think a total of 3 12AU7s, an AT7 and an AX7. Whereas this, I think we've got, let's see, 12AU7, 12AT7, 12AX7, AU7, AT7. I think this has two 12AT7s where the other has an AX7 and an AT7. I think that's the difference. So, I will have to puzzle this out. Anyways, I went ahead and pulled out some of these tubes, and let's see. One of the AX7As, it's an RCA. And the other one is an Amperex Bugle Boy AT7 made in France. Now, if I wanted to make a few bucks, and this is good, I should probably throw this on eBay. But for the time being, I'll hang on to it, because I do believe the audiophiles really like these Amperex Bugle Boy tubes. Have not checked the rest of them yet. Alright, so where does that leave me? Well, the other thing too is that it appears there may have been a little bit of work done in here. There's some cruddy looking solder joints down right in there. So for the time being, I am going to switch back to the Riders. And I think I might just start spiraling out from this area and see if I can start making some sense of things. So, if that is the 12AX7 shown here, the other problem is on this, they don't show you that there's no tube designators. It just says 12AX7. And if there's more than one, well, then which is which, I don't know. But that's 1, 2, 3, and I think that's the only one on the schematic. So 6, 7, 8, this has to be the other triode. And looks like that is pin 6, I think. Which it does have a 68K and a 10K going to it, and a 0.01 and a 0.05. So that may be correct, and it's just for some reason just a really horrible looking solder joint. And then we got a jumper wire over here, and then we got a 47K and a 0.01 and a 0.47. So no, something doesn't look right. There should be a 10K off of that point, and I don't see it. Got a 0.01, got a 0.05, got a 68K. I don't have a 10K, I got a 47K. Right there. Oh, what does the SAMs show? They also show a 10K. And I got a 270 down in here. So 68K, 10K, 0.01, and then there's a 270 going to ground. Very confusing. Well, I looked through every bit of service info I could find, all the revision changes, and nothing mentioned any change to this resistor value. It's always been 10K. And now that I'm starting to work in this area, I can see that some tinkering was done in the past, because as soon as I heated up this joint, these caps fell away. These leads have been clipped. Possibly somebody clipped them, took them out of circuit maybe to test the part or whatnot, and tacked it back in. I don't know. And I can see the fragments here of a cut-off component lead. So I am inclined to put a 10K here. And I'm pretty sure now that this is a replaced resistor, because it does not look like the same era as the rest of these. For example, here it's a 1 watt. I'm pretty sure, so it should look like this. Much wider bands and a smooth surface, not a rough surface like this. And that would account for this messiness down in here. I'm a little torn, because that 47K sure does match the look of the other parts, but I mean, who's to say where it came from? It could have been taken out of a junk box or something and tacked in there. I don't know, but yeah, I hate when this happens. But I do know on service info what the voltage is supposed to be at that point. So if it does not turn out to be 32 volts, I can go back and monkey around with that value, because that's what that 68K and the 10K are for. It's a voltage divider, should be 32 volts there. In fact, I could probably do the math myself if I can find out what the voltage should be on this main bus going through here, which goes around and around and around and around down to here, which I think says 260 volts. So maybe I'll verify that if that is 260 volts. I'll do a little mathematical calculating here and see what 68K and 10K would give me. But I can already ballpark it that if you use 47K and 68K, that's going to be close to just cutting the voltage in half, which would be significantly more than 32 volts on the plate of that sync clipper. This old service info is really, really detailed in the theory of operation. Here is this particular circuit, the sync amplifier and sync clipper, and here is the point we're looking at. So 68K, B+, and here is the resistor R100, 10K. This point should be 32 volts. And that's pretty important, as they show here, setting the bias and the gain and clipping the signal off at the right points and so on. So it sure seems to me that you better get that voltage right. Now they don't show B+ here, but on a schematic I looked and it is 240 volts. I did a simplified version here, so if we have 240 volts, 68K, we want 32 volts, what should that resistor be? And there's very little current draw at that point. Well, I pulled up a simple voltage divider calculator and plugged in and put 240 volts, 68,000 ohms, and we want 32 volts, so what should this resistor be? Well, there we go. 10,461, round that off to 10K. So that is what I'm going to use in the circuit. And I started to look through the rest of this, and this is definitely a very good read. Even if you're not going to work on one of these TVs, just for the theory of how early TV circuits blocks work. For example, like here's the integrator, where it takes the vertical sync pulses and integrates it and forms a vertical pulse to lock in the oscillator. And similarly for the horizontal pulses going through a differentiator. Vertical oscillator circuit, horizontal oscillator and control circuit. I didn't get too far before I found another area where there seems to be some monkey business, which is right here. The resistor looked a bit odd to me because it's not just because it's large, but because one end is looped around like that, which looks a little bit sloppy for production installation, and just happens to be a cap that sure looks like a replacement going to the same junction. And when I looked up, yeah, that should not be a 10K on either schematic. That is pin 1 of the sync amp. should be a 0.1 cap, and we've got a 0.05, and it should be 47K, not 10K. And Sam's agrees with that 0.1, 47K. So again, I'm inclined to go off of the service info and put things back, or not, well, maybe not back, but at least put things to what they indicate the value should be. And believe it or not, this is actually correct. Let's see if we could find that on the schematic here. There are indeed two resistors in parallel. I think I can find it most easily on the component locator. And notice that because you can see it right in the photo here. And if we trace this down, looks like it's R124 and 25. And here they are, 47K, 39K in parallel. So I'm guessing that was pretty important to have a somewhat oddball value on that tube, so they put those two in parallel. Also, of course, increases the wattage, but I think in this case it was more important to get a correct value than for heat dissipation.